This is a very short supplement to your vector tutorial number 3 on how to break vectors up into components. What this describes is a few helpful hints and tips for breaking vectors into components and some common mistakes that you need to watch out for. It's not difficult breaking vectors into components, but you do need to just take a little bit of care. So let's say I have a vector, here it is, of length 10 pointing in this direction, and I have a coordinate system, an xy coordinate axes, and my goal is to break up this vector into its xy components. The first step is I'm going to draw a triangle. I want to form a triangle such that the two legs of the triangle add up to the original vector. So I'm forming a right triangle. Make sure that the original vector that you're trying to break it up into its xy components, the original vector is always the hypotenuse of that right triangle that you draw. One leg of the right triangle should be parallel to one of the axes, and the other leg should be parallel to the other axis. So for example, I wouldn't draw my triangle like this, because even though this is actually a right triangle, this angle right here is 90 degrees. The original vector is not the hypotenuse of that triangle. And moreover, this leg of the triangle is not parallel to either the x-axis or the y-axis. So this choice is no good. So we're going to use this choice. Now, let me ask you a question. What about a choice like this? After all, here's a right triangle. One leg of the triangle is parallel to the y-axis and the other is parallel to the x-axis. So would this work? Absolutely. This is a perfectly good choice for drawing the triangle. I'm going to stick with this one just for illustration purposes, but there's no particular advantage to this one over that other one. Okay. When you draw your triangle, be sure to never, ever, ever forget to draw arrows on each leg of the triangle. This is important for two reasons. Conceptually, these are vectors. What we're saying is this vector plus this vector adds up to the red vector. And so you need those arrows for these to be vectors. Moreover, if you forget to draw the arrows on these things and you just draw like a line here and another line there, chances are you're going to screw up some minus signs a little bit later on, as I'll point out. So it's very important to make sure you have those arrows on each leg of your right triangle. Once you have your triangle set up, the next step is to compute the length of each one of these legs of the triangle. Now you're computing the magnitude or the length of this vector, and you're computing the magnitude or the length of this vector. Magnitudes of vectors are always positive, so you're always going to have a positive number for the magnitude or the length. If I look at this right triangle, I use a little bit of trig, and I can show that, oh, the length of this side is 10 cosine 40 degrees. The length of this side is 10 sine of 40 degrees. Notice there's no minus signs floating around, like this, for example, isn't minus 10, because when I put this here, that means I'm writing the length of this vector, the magnitude, and that has to be a positive number. I agree the arrow is pointing to the left, but the magnitude of the vector is still a positive number. And when you label vectors, you put the magnitude next to the vector, so that's always positive. Now, once you've done that, we're ready to break up this component into this vector into its components. So this vector here is composed of this vector plus this one. So what we do is we go this way for 10 cosine theta, and we're walking in the negative x direction. That's what this minus sign is doing here. I'm traveling this distance, so to speak, 10 cosine 40, but I'm moving in the negative x hat direction. Then I go here, and I'm traveling a distance 10 sine of 40 degrees, and I'm traveling in the positive y hat direction. So that's why this is positive y hat. So that's how you break the vector up into components. I want to emphasize that the way you choose these plus signs and minus signs is based on the arrows that you've drawn on the leg of your triangle. So because I drew this arrow and it's pointing to the left, but my positive x-axis is pointing to the right, that's why a minus sign appears here, because this arrow is pointing in the negative x-hat direction. Likewise, this arrow is pointing in the positive y direction. That's why there's a positive sign here.